Take down another problem based on Faraday's law of electromagnetic induction. In this problem we will be calculating the induced EMF and also the power lost as heat. Next you can write, suppose the loop in the given figure is stationary, but the current feeding the electromagnet that produces the magnetic field is gradually reduced so that field decreases from its initial value of 0.3 Tesla at the rate of 0.02 Tesla per second. If the loop has a resistance of 1.6 ohm, if the loop has a resistance of 1.6 ohm, how much power is dissipated by the loop as heat? First I will give you the figure also. Suppose the loop in the given figure is stationary, but the current feeding the electromagnet that produces the magnetic field is gradually reduced so that field decreases from its initial value of 0.3 Tesla at the rate of 0.02 Tesla per second. If the loop has a resistance of 1.6 ohm, how much power is dissipated by the loop as heat? Now here, first I will give you the figure and then we will try to understand the problem. The magnetic field is given. This is the given magnetic field and we have a loop inside this magnetic field. This is the loop which we are placing. Now this is 8 centimeter. And this is 2 centimeter. Now the loop is not moving, it is stationary. But what is happening here? This magnetic field is produced by an electromagnet. The electromagnet is the magnet which acts as like a magnet only when there is a current flowing through the current flowing through the coil. Now this is an electromagnet which produces this magnetic field. Now what we are doing is we are varying the magnetic field, but how we are varying? By reducing the current. or current feeding the electromagnet is reduced. The field is reducing with respect to time. So when there is a change in the flux linking the coil, there gets an EMF induced. So due to that EMF, there will be current flowing because it is a closed loop and the resistance of the loop is given. So you can easily calculate what is the power dissipated. So first we will use Faraday's law to find out the induced EMF. List out the given quantities. Given, I can write area of loop. A is, it is 8 multiplied by 2. 8 into 2, convert it into meter. 10 to the power minus 2 will become 10 to the power minus 4. So it is 16 into 10 to the power minus 4 meter square. Then what else is given? The rate at which the field reduces is given. The field is reducing at a rate of 0.02 Tesla per second, that is dB by dt. (0.02 Tesla per second). Now to show that it is reducing, you can put a minus sign here. The negative sign indicates that the field is reducing. Now according to Faraday's law, we have, by Faraday's law, induced EMF is given by E is d phi by dt, and if you want to write about the direction, then you can put a minus sign. This indicates that the induced EMF opposes the very cause producing it. So this is by Lenz's law. So combining both, you can write E is minus d phi by dt. And what is phi? Phi is B into A. Or d phi is the area d phi by dt. Now will become, the area is constant, it is not changing, the area of the loop is not changing, so it will be equal to A into dB by dt. Now substitute this value, so E is equal to minus d phi by dt, which is minus A into dB by dt, and area we already calculated, that is 16. Minus 16 into 10 to the power minus 4 into what is dB by dt, that is given, that is minus 0.02. Now combining this and doing the calculation, we will get induced EMF is equal to 32 into 10 to the power minus 6 volts. Now the next question is to find out what is the power lost. How much power is dissipated by the loop as heat? The power dissipated is given by, or power lost or power dissipated as heat, P is I square R. But what is I? I is E by R, where I is E by R. First calculate I. E is 32 into 10 to the power minus 6, and what is the value of R? It is 1.6 ohm. R is given, the resistance is 1.6 ohm. This 32 by 1.6 is comes to 20 into 10 to the minus 6 ampere, or I write it as 20 microampere. Therefore power is I square r, that is 20 into 10 to the power minus 6 whole square into 1.6, and this will come, the power lost as heat will become, now calculate this, 20 square and 10 to the power minus 6 square, that will become 10 to the power minus 12. So this will become 640 into 10 to the power minus 12 watts, or I can write it as 6.4 into 10 to the power minus 10 watts. Power lost as heat, or power dissipated by the loop as heat. Is 6.4 into 10 to the power minus 10 watts. Power lost as heat, or power dissipated by the loop as heat, as 6.4 into 10 to the power minus 10 watts. Now hope you understood this problem.